Okay, you understand? We already let you know. Next week, Monday, will be the review. And the final will be on Monday, 23rd. Okay? If you get C or higher, that means you passed the summer AC module. If it's not, I can let you make it up. And if you make it up still not part, you will be seeing me next summer. If you still want, you will get the certificate in this program. Okay, so last time we already reviewed to you on the band path and band stop filter. So quickly we get through it. So we will get into the new one, that means the complex number. Make sure you download the complex number in the handout. Okay, so on this one, and you know that will be a bypass, bandpass filter. Okay, basically they related into the resonance. Okay, and it on the band stop circuitry. Okay, so if you're looking on this circuitry, you need to recognize that will be the band stop. Okay, at the resonant frequency, the impedance of RLC series circuitry is maximum or minimum. A or B? You're telling me that A or B?
The answer is B. Minimum.
Yeah, B. That's just a resonance, right? At resonance, ICHL equal cancel out. So you can get only resistor. That will be asking you again on the final. So this is they just try to explain to you what's going on. You need to read it. At resonance, the output across the series LC circuitry greater than 28. Yes or no?
Yes.
Okay. I'm not telling you right or wrong. You will be do it in the final. If you're looking into this display, This is the output of what circuit? What type?
Band stop.
Perfect. Band stop filter. Okay, so now they show you that is the circuitry of the band stop filter and also the output. Okay, so that one you have to read it. They're talking about the frequency above or below the resonant frequency. Okay. Will the output signal increase or decrease of resonant? That means the frequency here and the frequency here
Increase.
increase, correct? That is a band stop filter. Okay. To reject or readily attenuate a small band of frequency, the bandwidth is
B.
B, correct, narrow. Okay, so this is another way. Connect for the band stop filter. Okay, that only thing you need to read it. At the resonant frequency, the input impedance of the parallel tuned circuit is very high compared to R. If out across the resistor maximum or minimum at the resonance.
Maximum.
LB.
A.
I don't know. That means I save it to you. Okay, make sure you try to review this handout over and over. First thing, you will be get your, when you're doing your left volt, you will be get through quickly. Okay, that will be give you get the left one done. Okay.
And Mr. Pham,
Yes, sir.
real quick, go back to that. Go back to that one.
Is it that one or next one?
Right here.
Okay.
Okay, even though it's a like a tank circuit, the X of C, the capacitor and the inductor will cancel themselves out because of resonance, correct? And then you will be left with the resistor only, and it'll be the drop across there as it shows in VO. So depending on the amount of the resistor, but it's small in this case. Is that correct?
I don't know. You say VL across resistor minimum. That's what you said.
Right, because the X of L and the X of C, I mean, we're dealing with resonance, so X of L and X of C cancels each other out. I don't want to stay on this, but you can move on to the next one. But that tank circuit, that's canceled out.
Okay, so if you want it, add me the time. The thing here will be go through that. And that's why you already know that one. Resonance frequency calculated by 1/2 pi square root LC. Okay, this one just for you for reading. Also, same thing. Okay, finally, they did play for you series band stop and parallel band stop. Only thing is, if you're looking into the circuitry, you recognize what type of the circuitry that be okay for you. Okay. Any other calculation, we not really care. This on the left volt, they go more detailed. However, on the textbook, maybe some is not. Okay, so that will be done. For band path and band stop filter, will be more questions in the final. Next week, you get a review. I will be giving you the question similar to the final, and we will help you clear. Okay. Any question on the band stop or band path filter?
The PowerPoint that you just reviewed, where's that listed in the class site, please? What's the name?
What the name? You know, you go into the handout.
It's on the web, right?
Right.
Mhm.
Okay, let's see. Okay, so today we'll be talking about complex number. This is another way to solving for the AC circuitry. Okay. Now, a complex number is a number of the form C equal A plus JB. When you see that form, that they will be in complex number, where A is the real number and B, they will be equal J equal square root of -1. So now you understand that you never get the square root of negative number. Okay. However, the definition for J in a complex number, they will be equal square root of -1. Okay. That's just a definition. The number A equal real. That's a real number. C and B equal imaginary part. Okay. In circuit theory, they used to denote imaginary component rather than I to avoid confusion. So now you can see the display right here. This is the real number, and that will be J. Okay. So basically, you have to understand a little more. What is J? Z mean you going from here to here. How many degrees? From the real, go to Z. How many degrees?
90.
Again,
Can you repeat the question?
that's what I said. From the real, go to up to Z. How many degrees?
90.
90.
Point.
This is 90 degrees, right? 90 degrees. So now, Z means rotate 90 degrees. Okay? And go Z from here, go here, they still rotate 90 degrees. Keep going. Okay? Geometrical representation. Complex number may be represented geometrically either in rectangular form or in polar form, acting on a two-dimensional plane called complex planes. Complex plane number C equal 6 plus Z8 represent a point where coordinate on the real is 6 was coordinate on the imaginary axis is 8. This form of representation equal a rectangular form. So now we on the rectangular form, you get two forms. One will be a polar and another one rectangular. Right now we're talking about rectangular. Okay, you get real here, you get imaginary Z. Okay, so if you get a point C right here, you're looking on to the real, that is number 6. And you're looking on the imaginary, you get number 8. That means 6 plus Z8. Okay, so on any question on this page?
And Mr. Pham, initially, when you read this thing, it says a complex number is a number of the form C equal A plus JB. And it says where A and B are real numbers.
B is a number, but on the imaginary.
Okay, so
That's
that's
why Z8, this is the number 8 right here.
right. And I was just looking where it says, in the when you read it, it says where A and B at the top, it says where A and B are real numbers. Then it says J equals the square root of -1. And then it goes back and says that A is a real number, part of C, and B is called the imaginary part. So it was kind of confusing because at the very top it called A and B a real number. Then it changed.
No, they not say B is called imaginary part. That's the imaginary part. That means they in on this part right here. They
So
still
only-
get, they
so
get the number,
So only A is real
right? That the A will be real,
and B is imaginary.
right?
All right, thank you. That's it. That's all I want.
Okay, any more question? Not we go. Now, you go to another one. Now they could be displayed on the polar. Okay. Complex number may be also represented in polar form by magnitude and the angle. For example, you see C equal 10 with the angle 53.13 degrees is a complex number, okay, with magnitude is 10 and the angle will be 53.13. This is magnitude and the angle representation is just an alternate way to specify the location of the point represented C equal A plus JB. That means the same thing like the other one. However, now they display in the polar form. And the polar form will be displayed by the magnitude and the angle. You can see there's an angle here, and this is the magnitude right here. This point will be the same on the other one, okay? Conversion between the rectangular and the polar form. So basically you get a rectangular here, and now you want to go converting into the polar. That's what they have you here, okay? First thing, you need to know what the value here, C. They will be calculated equal square root A square plus B square. And if you want to get the phase angle, then there will be a tan of -1 of B divided to A. That is the way to convert it, okay, from rectangular to the polar, okay? And now, from the geometry of the triangle, if you want to get A will be C times cosine of the theta, and B equals C sine theta, okay? So make sure that will be the formula you will be using all the time if you want to working with a complex number. Okay, up to this point, you get Q, okay? Either rectangular or polar. Try to display for the complex number. Okay, any question up to this point?
Yeah, excuse me, Mr. Pham, just a comment, correct me if I'm wrong. But I believe as we look at the formula and what you're showing as a XY grid with the phase angle of the signal, is it possible in a technician's responsibility that an engineer will hand them, say, 10 pages of what we see here on the screen, a formula, that each page represents a component and the location of the signal when it passes through a component. And when we're handed these pages, technically, we can design a schematic, or we can interpret a schematic, or look at a circuit board. And that circuit board is basically the representation of this XY grid. So if we're looking at this yellow little box right here, that's telling us exactly what the signal is of a particular component as it travels through the circuit. And we should have the ability to interpret just that yellow square and know what a schematic looks like, or where the component should be on a schematic, correct?
Okay, now, this not for your guy. This for engineering. Nothing to do with your job. Okay? This is another way in order to calculate the problem in the AC circuitry. Like, you know, you get RC series, RL series, or RCL series parallel. You can did solving the problem like we already did in this program. And now they get another way. If you go to the college, you will learn more theory, nothing related into the job on this calculation here. This is just another way. In order you can do your calculation for the series, parallel, resonant circuitry. Okay? So
Hey, Mr.
this is not related into any hardware, anything else.
Hey, Mr. Pham, these complex numbers are basically, we're dealing here with a right angle triangle, and you have C, and then C is equal to obviously the square root of A squared plus B squared, the square root. But if we're essentially just dealing with the right angle the triangle.
Okay, I'm said again, this is just another way.
Yeah, I understand that. I understand that.
Okay, so you know how come A equal C cosine theta?
Oh, you get that from the
Huh,
you get the, you have a triangle. One side is the hypotenuse is C.
okay, now you can see it right here. Okay,
Right, right,
right here. Okay, so one will be A,
right,
one
One-
will be B.
correct. And where the 10 is at is C.
Okay, this is a C.
Correct, correct.
Okay, so theta will A will be whatever. That's a trigonometry.
Correct.
Okay, so that's why I said we don't not go into the detail trigonometry. However, you need to memorize those two formulas. In order you can do the job.
Yeah, it's
If you
right angle.
want-
here.
If you want complex number to solving as AC circuit.
Yeah, the cosine is A over C,
Yeah,
and the sine is B over C.
right.
And the top formula here gives you the magnitude, where the bottom formula gives you the angle.
Exactly.
Okay, thank you.
It's right angle trigonometry.
Right. This is the handout today, not in the quiz or in the test. Okay? This I just try to see who want to learn a little more about the AC circuitry. Okay, any question up to this point? Okay, now. Example. What they want determine rectangular and the polar form for complex number C, D, V, and W of the figure shown. So what they want the rectangular for point C and also polar for point C. And point C, let's see, CD, right here, D. Okay, V right here. And W here. Okay. Now, point C. What's the real part?
4.
4.
Or
You're going down. Okay. And what imaginary part?
3.
3,
3. So that's why in the rectangular you get C equal 4 blood J 3. Right?
right,
Now in polar, C will be square root of 4 square plus 3 square equal 5. And the fair angle 10 minus 1, 3 divided to 4, 36.87. So in the polar, okay, they will be equal 5 angle 36, 87. Right or wrong? Correct? Any question on that? If you want to go to the college, university, that's what you need to understand. Now, on that one, in the polar, you can see, let's see right here, angle 36, magnitude 5, okay? And now they calculate the point D. Point D right here. Without looking into the answer, can you tell me exactly what the rectangular is supposed to be? By looking into here, you can see right away, right? Point D will be 4. And minus 4J. Correct?
Yes.
Yeah, you can talking about right away in rectangular. W. Rectangular.
-4 plus 4J.
4 minus 4. Right?
Yes.
It's a real. So they will be a minus 4.
That's
Not-
your A, and 4 is the imaginary, so that's B.
Right. Minus 4 plus J4. That's W. And the angle, you have to do calculation. 10 minus 1 of B over A. Okay? And now I want to know what for this guy here.
0 minus 4 minus 2.
Equal what?
Real 0. Imaginary minus 2.
What you get for V? Rectangular.
0 in real.
What the real for V?
0.
0. Correct.
0. Yeah.
What J?
-2.
Right. Now, they did play for the point C and point D. You're looking into that, see any comment, right or wrong? Okay, so you understand a lay of point C we already show you. You have to get magnitude and the phase angle. Okay. Now, on W, they will be telling you -4 plus J4. That will be in rectangular. In polar, okay, W equals square root 4 square plus 4 square, 5.66, and the phase angle minus 4 divided by 4, minus 45. Okay, so basically that will be a 90. Okay, and you're adding 45. angle will be 135 degree.
Hey, Mr. Pham, real quick question.
Yeah, no,
Now on the X, the Y axis, no, I'm sorry, the X axis is always the real axis, correct?
exactly here.
And the Y axis is the imaginary axis.
Right,
Yeah, I just want to make sure I get that right. So
Right.
that's why you got a -4 for the W equal -4 plus J4.
right,
Because the -4 is real and the +4 is imaginary.
right.
Okay, thank you.
Same thing on Z. This is Z. This is minus Z.
Right.
Okay, point V. In a rectangular V equal Z2. No real, right? Real 0. Correct?
Right.
So in the polar, you know they're going down here. They will be
Should that be -90?
minus 90, not 90.
Right, so it should actually say V equal to -90 degrees.
Exactly. Janet, minus 90.
Mhm.
Okay, going up, 90. Going down, minus 90. Okay, thank you.
Or 270.
What?
270.
No, we don't get it around here. Okay? The thing is you understand, normally when they go up, you get 90. When they go down, you get minus 90. The thing is minus 90, the same thing with the 270.
Hey, Mr. Pham, I got a question right before you leave that. On the one where you're doing W here, where you got 5.66 and you got 135 degrees and you have 45 degrees, is 135 degrees, is that the same as a -45 degrees or?
Now,
I
the
guess-
thing is when they on the J positive, okay, then the angle is supposed to be go this way. Okay, they will be go this way. Okay,
Okay,
so that's why you know that is the, when you calculate it, you can see they get a differently 45 degree. So you have to take the 180 minus 45.
Mm,
However, when on the other side, okay, then you know that it will be a 90. Okay,
okay. And what I'm asking is, I know what you just said is 135 degrees, but if you was to say 5.66 at -45 degrees, would that be wrong?
no. So
It
they
was-
can misunderstanding a 45 minus right here.
Mhm,
This is minus 90.
mhm.
Okay, this is minus 45.
Okay, so it's better just to say 135.
Yeah, when they positive.
Okay,
I have a quick question on that one.
Yeah, okay.
If, just theoretically speaking, if it was instead -4 minus J4, would it be a 566 at -135 degrees?
566 is correct for calculation the magnitude, right?
Yeah.
Fair angle. Okay, when you calculate it, you get minus 45.
Mhm.
However, the point will be on the positive side. Okay, from here to here.
Mhm.
Then they want the angle will be this one.
Okay,
Okay, so that's why you know you get a different 45. So they get 180 minus 45.
okay.
That's telling you angle will be 135.
but her question was, if your real was -4 and your imaginary was -4, what would your angle be when you go to polar?
You mean the here right here, right?
Yeah,
Okay,
Okay, if the real right here, so basically you can count from either way. If you go into this way right here, right?
mhm,
So you can get the 180 adding to whatever number here.
okay,
However, normally they go this way,
okay,
okay?
okay, thank you.
You are welcome. Now, J. You understand J by definition equals square root minus 1. So they calculate J square. Now see what you get. J square equals square root minus 1 times square root minus 1. So the answer will be minus 1. Do not try to take minus 1 times minus 1. That's wrong. When the square times square root times square root, you just remove the square root. Okay? If you get a question, let me know. J power of 3. J power of 3 will be J square times J. And you already know J square is minus 1. J
so minus one times J is minus J.
yeah. J power of 4. J square times J square. J square is minus 1 times minus 1.
Minus times a minus is a plus.
Yeah, you get 1. And now they want to say minus J times J.
That's, so that's, minus J is, let's see. So wouldn't that be like a minus J squared? Yeah, minus J squared. And since J squared is minus 1, then minus J squared is 1.
Correct.
Because if you look at the top, the top says that J squared is equal to minus 1. So then minus J squared has got to be the opposite of minus 1, which is 1.
Correct. And that's just they given to you some few calculation, like they say 1 over J. Okay. To see what our 1 over J equal. So now they prove it. 1 over J times J over J. J over J, that's just a 1, no big deal. So when they times 1 times J, you get J. J times J, you get J square. And J square is minus 1. The answer for 1 over J, same thing for minus J. Okay, any question? No, if not, go here. Example. Given A equal 2 plus J1, B equal 1 plus J3. They want to know the sum and the difference. Okay. They already given the solution. I will go through it, but I will be telling you when you want to adding subtraction, you will be using rectangular form. However, if you want to multiply or divide it, then you better using the polar. Okay. Now, given A plus B, 3 plus J4, and A minus B, okay, 1/2. Okay, so multiplication, division. So come like A equal 3, angle 35 degrees, and C, B equal C, minus 20 degrees. They want to know product A and B, and quotient A divide B. So A times B, okay, that means you can time 3 to 2, and the angle will be add them up. Okay, so let's see, 3 times 2, okay, they're supposed to be 6. Angle will be minus. They will be adding up, not a minus. However, this is a minus here. So that's why 35 minus 20, you get 6 point, angle 50. If you divide it, you take 3 divided by 2, angle will be subtracted. Okay, that means you get 35 minus 2 minus 20, you get 55 degrees. Finally, add, subtract using rectangular form. Multiply, divide using polar. They given you the polar here, A times B. Then you take the root A times B. Angle will be A plus B. Divided, you divide real number. Okay, and the angle will be phi of the A minus phi of the B. That's just the formula. And when we're doing the example, to make sure you understand. Now, you try for me. Do maximum you can. First, number 1, you get A, B, C, D, E, F, Z. Try to get it done quickly and telling me what is the answer for each one. If we not complete it today, then the next week you will be get 2-day lecture. I adding 1 more day. Okay, for both, for complex number and for the review. That means next week maybe you can get Monday with me, Tuesday with me, okay, and Wednesday and Thursday with Mr. Tai. Depend on what's going on today. So go ahead and try to do exercise number 1. When you get into the last one, then I try to collect the answer. And I given you the right answer. That means number one, they given you rectangular, they want you polar. Okay, I can give you number A.
690.
Okay, polar will be
6 at 180 degrees. Oh, 90. That's right, 90 degrees. Because it goes to the right.
80.53. 90?
B.
4 minus 90.
Okay, let's see. B, 4.
Okay.
Angle,
Negative
Ah.
90?
Minus 90.
you understand a minus mean 90 degree.
Four 4.24 with angle 44.
What angle?
The angle for number C is 45 degrees.
45
Yeah,
degrees.
45.
Okay, the answer will be 4.24. D. Yeah, your guy doing very good.
Did anybody, for D, did you get the angle 33.7?
69, but yeah,
What the angle? What the-
33.69.
Okay, now. What the magnitude? D.
7.75.
Yeah, is it 4.47?
Oh, how come I get the difference?
7.2.
I got 7.11 or 21, I think.
21. Correct.
21.
7.21. Angle.
55.
Who else?
I got 33.69.
I also got that.
56.3.
63.43.
56.38. Okay, but they have to be minor.
Mm.
So it's the 33.69, but it's 90 degrees minus that. Gives you 56.30. No?
Is this letter E?
Yeah, that's D.
That right now be on D, right?
No, for letter E.
I think we're still arguing about D. So
Okay.
I
So
got
for-
the original calculation of 33.69, and if you take 90 degrees minus that, you get 56.3,
I got the same.
but it has to
No,
be a
minus
negative
23.
56.3.
That's the correct answer.
I forgot the minus 90.
Okay. A, B, C, D. E.
9.4.
9.43. Correct.
Minus 7.9.
What the angle?
122.
122.
I mean, minus
No,
57.
not nine minor.
Okay. Okay.
The thing is, you have to thinking, okay? If not, try to copy, make sure you understand how they get that answer. F.
Sorry, I missed. What did we say the angle was for E?
122.
Okay.
Basically 122, not 23. Okay. Yeah, if you can do it, then you can go to the college, no problem. I've been teaching for very long time in my life. I can see what the students do it. And I can recommend, okay, you can keep moving up. What F?
2.2.
2.24.
2.24, that's correct. What angle?
minus 63.4.
Angle minus 63.4. Perfect. And the last one.
Three point six.
3.61. Okay. 0.6, that's okay. But angle,
minus 123.7.
perfect. 1, 2, 3. That is the correct answer. Okay, now go ahead and try to finish number 2. They want converting to rectangular form. The reason why I want you to do the thing is the rest of solving RC, RCL parallel series circuitry will be using converting to polar or polar to rectangular all the time. So if you cannot get through this thing, then it's hard for me to take you apply into the RCL circuitry or the resonance, whatever calculation we did before. Now you can do the new way. So for the rectangular, you need to calculate A and B, and also know to put the J.
The answer of A is J4.
A will be J4.
B
D
is 3.
is 3. Yeah.
B will be three plus J0.
Minus G2.
Yeah.
E is the 3.2 plus J 3.83.
Let's see, D 3.83. Okay, plot J 3.21.
I think it will be the opposite. 3.2 plus J 3.83.
For E, what do you get?
It's correct. 3.8 is real part.
I got the same as you, Mr. Fang.
Yeah, yes, is the correct answer.
Who else? Okay, I gave them to do the answer. Minus 3.
Plus 5.2 J.
Yeah. Plus J 5.2.
F is 2.35 minus J 0.855.
Perfect. 2.35. Minus J 0.855.
Yeah.
Perfect. And the last one, G.
Minus 1.644.
Okay. Minus 1.64.
Mm-hmm. Minus 0.6 J.
0.0599.
Well, yeah, 599, so 0.6.
Okay, basically on the example, they're going to converting it, you get a rectangular, you're converting to the polar, or you get a polar, you're able to converting to the rectangular, no problem. Make sure you must be review it, exercise, do it without thinking. That means you can solve it right away. In order to apply into solving the AC circuitry using complex number. Okay, up to this point, any question to me? If you understand this thing, when you want to solving the AC problem, then you better using the complex number. More easier for you. But what I'm saying on the test, I'm not asking about complex number. But you can use the complex number to solving AC circuitry to get a right answer. Okay, any question?
Thank you, Mr. Pham.
Yeah. Do you have anything to say? Okay, if it's not, I will stop here. Next week, you will be get 2 meetings with me, Monday and Tuesday. We need more time. Okay? The thing is, if you're looking into here, you see, next week will be applied into the AC circuitry using the complex number. Okay?
So Mr. Pham, so it's no digital next Tuesday?
Next Tuesday will be with me. Then what?
Tech 1, no Tech 2.
No Tech 2.
Okay, so next week, no Tech 2 then.
Next week is after next week. Today, this week you get Tech 2 tomorrow,
Right,
right?
right.
But next week will be no Tech 2.
Okay, all right, thank you.
Okay, if you no question, I will be get off. Okay, we'll see you guys next week.
Good
Thank you,
night.
sir.
Good
Thank you.
night.
All right, all right.
Bye, everybody.